Hello everyone, welcome back to our channel. So in today's video, we'll break it down the very important concept of Newton's second law. So it is a part of dynamics and it is very easy. Just you need to draw the FBD as well as the kinetic diagram. Okay, so it is a part of kinetics. So motion and the force causes that motions are considered in this topic. So we'll start with the statement. So problem statement is a 500 Newton crate is on a 15-degree slope. Mu is equal to 0.4. If pulled down with the initial velocity v0, 20 meter per second, find the distance traveled during coming to rest. So as clearly shows, a friction is involved in the dynamics problem. So it's most likely the problem related to the Newton's second law. So in this way, you can identify from which model it was asked. Friction plus dynamics. So most likely it is in a kinetics or Newton's second law. So this is a given statement. So based on this, we can draw the figure. So block of 500 Newton is kept on the slope. The angle of slope is 15 degree and it is moving down. So its initial velocity is 20 meter per second. So after traveling some distance, it will come to stop. Now tell me why it will come to stop if you know the logic. The reason is very simple because the friction exists between the block and the surface. So that causes the reduction in the speed. So instead of getting accelerated, its speed will retard it as it travel the distance. So after some time it will come to the rest. You need to find the distance traveled from this point to this point. That should be your answer. So we'll start with the given data. The weight is given, angle is given, coefficient of friction is given. It may be mu k or mu s. Initial velocity is given, final velocity is 0 because it come to rest, so final velocity becomes 0, and finding will be distance traveled before coming to rest, so this will be the distance x. So we'll start with the FBD of this figure. So here we consider the coordinate system. This will be x and this one is y. Okay, identify it and we'll make it horizontal. Though it is an inclined object, we'll consider it as a horizontal object just like this, and these are the coordinate system or the axis for the block. So this is x and this is the y. So when we convert a inclined object into horizontal object, so the only inclined force here is a weight force. So this, if you see carefully, the weight force will act in the fourth quadrant. So show the weight in the fourth quadrant. The value of weight force is 500 Newton. Okay. Now the angle of weight force with the horizontal will be 90 minus angle of the slope. Remember, the angle of weight force with the horizontal will be 90 minus angle of the slope. So it should be 90 minus 15. So that is nothing but 75 degree. Why we are doing this arrangement? To simplify it, to avoid the mistakes, we are converting this inclined plane into horizontal plane. That is the only trick. Now show the normal reaction. It is perpendicular to the surface and it is towards the center. Now understand the motion. The block is moving in the downward direction, right? So it is moving. If you consider this coordinate system, it is moving towards right. So here also will show the direction towards right. So it indicates the motion. So friction force will always act opposite to the motion. So this is the friction force acting opposite to the motion. The value of friction force is F is equal to mu into normal. The normal is N1. So we have kept its name N1 because sometimes students get confused between N and the unit Newton. That's why, to avoid confusion, we'll write it is mu into N1. The value of mu is given, that is 0.4 into N1. This is called as FBD. So it includes the weight force, the normal reaction, and the friction force. No any external force is acting on this object. So based on this FBD, for Newton's second law, we required one more thing that is called as a kinetic diagram, or simply we called it as KD. So it indicates the motion acceleration of the particle. Now this particle is moving towards right, so its acceleration is towards the right direction. So as per Newton's second law, force is equal to mass into acceleration. Now this object is moving in the x direction. So we'll consider its acceleration in the x direction. So first show the motion or direction of motion where it is moving. It is moving towards the right, and it is equal to mass into acceleration. So m into acceleration in the x direction. Now the mass is not given. Instead of that, weight is given. So convert this mass in weight into mass. So W is equal to mass into gravitational constant. So if you divide this W by G, we'll get the value of mass. So 500 divided by 9.81 into acceleration of this block in the x direction. This way we can find. Okay. Now this block is moving towards x direction. It means its acceleration in the y direction will be 0. Acceleration in the z direction must be 0. Okay, now we'll start with the Newton's second law of motion. So applying Newton's second law of motion, we'll write first one in the y direction. So it should be summation of Fy is equal to mass into acceleration in the y direction. So write the equation. The vertical components are n1 plus now this weight force act in the fourth quadrant, so its y component should be negative, so it is 500 sine 75. So n1 minus 500 sine 75, it is equal to mass will be 500 divided by 9.81 into acceleration in the y direction is 0 because it is moving only in the x direction, so that's why this becomes 0, and so whole right side becomes 0. So n1 is equal to 500 sine 75. Find out the value of 500 sine 75. So N1 will be equal to 482.95 Newton. This way we have calculated the value of N1. Now we'll apply the Newton's second law of motion in the x direction. So we'll write the equation here. Summation of Fx is equal to mass into acceleration in the x direction. So write the equation. The horizontal forces here are, first one is a weight force. So it lie in the fourth quadrant. So x component is positive. So it is 500 cos 75 minus mu into n1. The value of mu is 0.4. Put that value. So here minus 0.4 into n1 plus 500 cos 75. It is equal to this component. 500 divided by 9.81 into acceleration in the x direction, that is acceleration of block A. Now again consider the sign convention for the acceleration. If acceleration is towards right, it is positive. When the acceleration is upward, we'll consider positive. Acceleration toward left side is negative. Acceleration in the downwards direction is negative. So we'll keep the same sign convention as like the force. So this way we can write the equation. Now solve this equation by putting the values and get the value of acceleration. So here the acceleration is equal to minus 1.252 meter per second square. So first find the answer for this part, then divide it by 500 and multiply it by 9.81. We'll get the value of acceleration is equal to minus 1.252 meter per second square. The negative sign shows that the speed will retard after some time and it will come to rest. Okay, but finding acceleration is not the exact solution. You need to find the distance traveled by the block before coming to rest. So here we use the equation of motion. V square is equal to u square plus 2as. So put the values here. The final velocity is 0. It will come to rest. Initial velocity is 20 given. Acceleration is minus 1.25 something that we have calculated, and this is the required distance. So we'll put the value 0, 20 minus 2 into 1.25 acceleration into displacement. So here displacement value we'll get is 160 meters. So the block will travel 160-meter distance before coming to rest. So this will be your final answer. So always remember Newton's second law will be force is equal to mass into acceleration. And in this question, a combination of friction and the dynamics will be asked. So from that you can identify, even some dependent motion questions will be there in the final examination. So you have to draw the FBD as well as the kinetic diagram. Kinetic diagram will have the component of mass into acceleration. So as per the direction, you can see the show the mass into acceleration. Then apply the Newton's second law. Summation of Fx is equal to mass into acceleration in the x direction. Summation Fy is equal to mass into acceleration in the y direction, and find the required values. So if you understand the question solved in this lecture, kindly like our video, share our video, and thank you very much for watching this video. Thank you very much.